Very well. So we are here in the third notebook that we will be using in this course. Let's run the first cell with some required libraries. And the first thing that we are going to do is to open the words text file that we created in the previous step. We are loading this content of every single word, and we are feeding it into the unique words list. Here, if we execute this list, unique words, we can see that we have all our words in alphabetical order. Let's clean this for now to keep this clear. Next, we're going to take all the list of words and we will put it in a single line of text. This is just a way of doing it. I want to use the list as text to actually use my tokenizer to use the very same functions that I will be using in my tokenizer. But if you want, you can handle it in a different way. You can just create your tokenizer using the Python list. But in this case, I'm going to create a single line of text that includes every single word. So let's execute this line here. And if we want to see what is it that I created, let's show it. List as text. So basically it's the same list that we had before, but now it's a single text. Okay, that's basically it. As we saw in the bird case, that tokenizer has special tokens, and our tokenizer will also have special tokens. The special tokens that we will be creating are these four. We're going to create a start token, an end token, an unknown token, and a pad token or a padding token. The start token will be used every time we start an input to the model. We will prepend it with this special token. As we train the model, it will learn that every time it finds this special token, there is a new context or a new concept coming up. So it helps the transformer to understand when an idea is starting. The next token that we will be defining, the next special token that we will be defining is the end token, which is going to be an end of sentence token. This is it, the EOS, and it will be appended to the end of every single sentence that we want to pass to the model. And again, this is a way to tell the model that these are independent concepts that the model should take care about. So these are special tokens that we are deciding to implement. In the case of GPT-2, it uses the end of sentence and the start sentence. Then we have the unknown token. It can happen that some of the input that we use is not contained in the list of the words of our tokenizer. For example, you saw that I excluded every number and I excluded every punctuation symbol. If we pass to the tokenizer one of these symbols, for instance, I pass a question mark, that's going to be unknown to our tokenizer. So we have to have a way for the tokenizer to handle these special cases. And for that, we have the special token called UNK, unknown. Finally, we will be defining the pad or padding token. What this is about. Models have a maximum size that they can ingest, but the input that we will be providing is many times smaller than that amount. For example, if the model is designed to intake 512 tokens, but we give it an input with only 100 tokens, the rest of the spaces are left blank. And actually are not left just blank, they are filled by random information. So we want to make it a uniform information, telling the system or telling the model that this is not part of the content anymore. And for that we use this padding. So basically, anytime we have content that is smaller than what the model can ingest, we use padding to make every single input of the same size. So that is why we're going to be using this special token called pad token. The most basic function of the tokenizer is the tokenizing function, which takes a text and returns a list of each individual token in that text. This is the next one that we're defining here. We're basically using regular expression to separate the words from periods and commas. Remember, we are building a very simplified tokenizer. in production-grade tokenizers, words are many times split in subwords. Also, production-grade tokenizers use symbols and use numbers. Whenever you're going to build your production-grade tokenizer, make sure that you include all that. Now that we have the tokenize function, we can test it, and we're going to pass a text. In this case, this is a text of our tokenizer. I'm going to use the tokenize function that we just created here, and we will print it to see what is the output. And as you can see, we are returning every single word separated, so we have tokenized the words. That's amazing. You may ask, where are the special tokens? Well, we still haven't embedded that concept into the tokenizer. We are only taking the text and splitting it into tokens. That is kind of a primitive function of the tokenizer that we're building. Now that we have a tokenizer and we have the list of words that comprise our vocabulary, let's build the vocabulary for our tokenizer, passing the list as text that we define above through this function. So here I'm going to take the list as text variable that I created above, and I will convert it into all our tokens. Let me run this. Let's make sure that this is unique, and let's make sure that this is ordered alphabetically. And now we're going to take all these words from the A to the Z, and we will append our special tokens. For that is the cell where we take every single token from the unique tokens that we just created here, and we will then append the 4 special tokens that we defined for our tokenizer. Let's run it, and let's see the first 10 and the last 10 tokens of our vocabulary. Here we have the first 10, abe, abac, abandon, etc. And here we have the last ones. It ends with zelos, zenith, zest, zoo, and then we have our special tokens. In my case, I decided that the special tokens would go at the end of the list. In some cases, the special tokens come at the beginning of the list. If you explore BERT, tokenizer for instance, you will see that these special tokens are around the token 100, 101, 102. And if you look at the entries before that, from 0 to 99, and from 105 to 999, you will see that the engineers that built the BERT tokenizer reserved some spaces for future enhancement of the tokenizer. So basically, they took the very first 1,000 positions of the vocabulary array, and out of those are only using like 4 or 5, and the rest are reserved for future improvements. So that's a nice idea that you may want to keep in mind. But basically, the main takeaway here is that you can define whether you put the special tokens at the beginning, at the end, mixed. My recommendation is put them all together. It's easier. And also, you may decide if you do as the smart guys of the BERT tokenizer, who left some additional tokens for future usage. Now that we have our unique set of tokens, the next step is to assign a unique index to each one of those. And for that, we will build a couple of helper functions that will help us with that. First, I'm going to create one that converts words to indexes, and then I'm going to create one that converts indexes to words. So let me run this, and let's look for the word rose, and let's see what ID it was given to it. It was given the ID 6763. With this other helper function, IDX to word, I'm going to convert the 6763 into its word, which is, as expected, the word rose. As you can see, and we said it from the beginning, the tokenizer takes a word and converts it into a number. And that's exactly what we're doing here. And the tokenizers of each model that exists have their own vocabulary, their own IDs. So let's make sure that you understand that and that you never try to use one tokenizer of one model in another model.